Okay, welcome everybody. I'm delighted to see so many to this seminar on silt pollution on construction sites. As you will have guessed, it's brought to you by CECA, but also in conjunction with Frog Environmental, who are obviously going to do the majority of the work. For those who don't know me, I'm Peter Crossland. I'm the National Civil Engineering Director for CECA, and I also provide the Secretariat for the CECA Environment Group. And I know a couple of the group are actually on the call, and given the discussions that we've had on silts at our meetings, I'm sure this is going to be a really engaging session. Just to let you know, there has been a slight change, and you'll probably see from the name on the slide in front of you that we've had a last-minute change of presenters. Unfortunately, Leela Aday, who was going to deliver the webinar, is suffering with a chest infection. So rather than try and struggle through the webinar, Leela has persuaded her managing director, Richard Hain, to step in. And so a huge thank you to Richard, and I'll let Richard introduce himself shortly. But before we kick off, just a little bit of housekeeping, if I may. I think you're all aware that this session is being recorded, so hopefully you're all happy with that. And CECA will communicate where it will reside in due course. Also, could I ask everyone who has a question for Richard, could you hang fire and wait till the end of the session, but please add it to the message box and not the chat box, just so that we only need to monitor one at a time. So if you can put your questions in the message box, that would be really appreciated, and Richard will do his best to respond. The timetable is roughly 60 minutes. But Richard is fairly flexible on this, so if the conversation's flowing, and he's already said he's happy to extend beyond the hour. So we'll see where we are at 5 o'clock. With regards to cameras, there's no particular requirement to have them on, but it would be nice if for those who want to add your camera, it would be useful. Richard at least knows he's got an audience, but you're not obliged to. We will be sending a feedback form. This will be sent out via a link after this session. Well, I'd be grateful if you could complete it. And it's always good to know how these sessions land with members. And also, any suggestions for other topics is always useful. So please feel free to add in. And finally, from me, we'll be providing CPD certificates for this event. They'll be generated by Frog, but they'll be emailed out by CECA. And before I forget, thanks to Frog Environmental for putting this seminar on, and also to Jennifer at our Yorkshire and Humber office for all her help. So without further ado, I'll hand over to Richard for the webinar. Thank you, Richard.
Hi, Peter. Thanks very much for the introduction. Yeah, I'm Richard Hain. I'm Managing Director of Frog Environmental, and thank you all for joining us for the session on managing silt pollution risks on construction sites. So the agenda today, we'll look at some of the environmental impacts and the business risk of silt pollution, think about the legal and permitting requirements, try and get into the underlying causes a bit of silt pollution, because that's interesting. Getting down to the underlying cause can help us solve those problems of silt pollution. Go on to look at some principles and techniques, and we're actually going to touch on the economics of silt control as well today. Before we get going, a quick introduction about Frog Environmental. We are silt control specialists. We design, manufacture and distribute silt control equipment, and we support many different types of businesses and contractors on site with their technical problems. We also design and deliver bubble curtains, which can be used for silt control as well, but also have a range of applications in marine and inshore environments, including things like sound attenuation. A couple of key themes that we're going to touch on today. First of all, silt is a damaging pollutant to the environment. Your site needs to be ready year round. It's not just a winter problem. So we do talk about rain ready, having a site that's ready for that summer deluge as well as the winter deluge. And we do see some really bad silt pollution events happen in the summer. Most of the silt pollution events we see on site are actually avoidable. So there is hope, but you do need good planning to get it right. And that's going to be another theme that's going to come up again and again, that planning aspect. So first of all, why do we need to prevent silt pollution? There's a few good reasons there. First of all, we're responsible people working for responsible companies or responsible organizations. We want to prevent environmental damage. We want to make sure our site is legally compliant, and in doing so, reduce that business risk. And also, when we're doing anything on site, ultimately, we want to look for efficiencies. We want to try and reduce costs as far as practicable. Just before we get into the nuts and bolts of it, it's worth just putting a definition on silt pollution, because silt is a naturally occurring part of any fluvial or river system. Obviously, it's from weathering of rock, bedload transport. So silt's naturally occurring. So when we're talking about silt pollution specifically, we're talking about silt entering a river or a water body typically that shouldn't be there. So from an anthropogenic source, such as mining or a construction site, or indeed remobilizing silt in an unnatural way that might already be in a river system that could then cause a knock-on effect downstream. So let's look at those environmental impacts for a second. Habitat degradation is pretty well understood that large loading of silt can really reduce spawning ground for fish. It can have an impact on the aquatic food chain. It's also a vehicle for pollutants entering the water. So that can include things like higher nutrient loads that might have more acute impacts, introducing a higher biological oxygen demand into the waterway, for instance. And it could have things that have chronic impacts as well, things that you might not want in a river, heavy metals and such, like things that might be attached to that silt that can end up there. We're also seeing it cited a lot in terms of increased flood risks, particularly where we're seeing large construction sites upstream of flood control structures. Business impacts are a bit more dynamic. Certainly enforcement actions and fines is a pretty obvious one. If you do cause an incident, you're going to have to respond to it. So there's kind of some hidden costs there as well. Those hidden costs get to the surface pretty clearly if your site is put on stop. And we do see that, unfortunately, sites stopped in their tracks. And really that can start getting very expensive if you need to stop working completely while you get your act together. If you really cause a big problem, you could have cleanup costs. And that last one there, damage reputation, is an interesting one as well. I think most of us probably here are sort of working out how to navigate the digital era that we live in, perhaps both on a professional and a personal level. One thing that's really, really clear is that if you do cause a silt pollution incident, you're very likely to be making headlines for all the wrong reasons. And I think in this digital era, it's pretty easy to get a damaged reputation when a reputation that can be built over many years can be lost overnight potentially. So there are risks here, and much wider risks than just the local business or that project, but much wider business risks. Responsible people, we've got to comply with all the relevant legislation. Now, there's lots of different legislation here. I'm not going to go through it all, but none of that will cite silt specifically. But if you do cause a silt pollution event, there's lots of different regulatory instruments that you could be prosecuted under, including things like the Environmental Permitting Regs, the Environment Act, Freshwater Fisheries Act. It all depends on what you've damaged and how badly you've damaged it. Bit of myth busting for you here. I mean, something that we do hear quite a lot on site is that because a site's got its plan in place, they've got their drainage design, it's all been signed off by the lead local flood authority, that they've got a permit to work, they've got a permit to build. If you're on site anywhere 3 months, certainly in England and Wales, car license is a bit different in Scotland, but if you're on site for 3 months or more, you will need a bespoke environmental permit to discharge water during your temporary works phase. And that's perfectly logical, isn't it? Because, you know, when a scheme's finished, the actual environmental impacts, provided it's well designed and been approved, are very low. But those environmental impacts during the temporary works phase are actually pretty significant when it comes to silt pollution and actually connecting a source to a receptor. Recently, polluters now face unlimited fines. I mean, there you go. There's a consultation recently. £250,000 cap is being removed, and that relates to the variable monetary penalties that are imposed directly. So that gives the regulators a way of actually finding a quicker method without having to go through those court costs, which can be very costly. You know, ultimately, all the regulators have got a budget that relates to being able to take people to court, but they've now got a better mechanism for actually for finding people a bit more quickly and easily. And we know that's going to come into play for silt pollution, because we are seeing some pretty big six-figure fines over the last 12 months. I should say that doesn't excuse you. If you really get things wrong, there's still a very high chance you're going to end up in court, and there will still be a budget there. But I think it's very clear to us that the risks of causing a silt pollution event are changing. And I know this is lots of information on this slide, but I think it's worth taking a step back and actually thinking about all those risks and what they are and the different drivers here. You know, we've got people care about rivers. Certainly, they're more in the news at the moment. Pollution has become higher profile. Probably the pandemic contributed to people enjoying the green and blue spaces on their doorstep a bit more. We see more volunteering, more citizen science taking place on rivers. That's leading to more reporting to the regulators from members of the public. We're certainly seeing a changing regulatory attitude and legislation. More fines, more severe fines. We've got the prospect of climate change, more intensive rainfalls predicted. How's that going to impact how we manage surface water during temporary works? There's a skills gap in the construction industry regarding silt control. It's quite a specialist area. Not many people are particularly good at it. Construction sites are also a very visible target. Adding to that silt is a highly visible pollutant, and you've got a bit of a perfect storm there. And I think ultimately that's why we're having discussions like this, CPD sessions like this, and that's kind of why it's moving up the agenda. So we know silt causes environmental damage. We know the business risk is increasing, but we still see lots of silt pollution events happening. So from our perspective, it's worth asking why, because we do still see lots of silt pollution events. And to understand that, it's really worth thinking about those underlying causes. And we deliver a whole module on this in our half-day training, because I think if you can get down to the underlying causes, you can sort of come up with systematic and process-driven solutions rather than just sticking past the solutions. Now, I'm not going to run through these all at the moment, but I would just like to pick out a few of my favorites, if you will. First of all, that lack of training and knowledge, that skills gap that I referred to earlier. There are people on site who don't understand that silt is a pollutant, and that's not good enough. They might understand that diesel or hydraulic oil or anything has to be stored in a certain way as a pollutant, but just getting that baseline of knowledge to everyone on site, making them understand silt is a pollutant, you need to report it, it needs to be managed. The other aspect of this is that, I mean, from our anecdotal experience as practitioners, if we go to site to talk about silt pollution or help on a technical front, we could be talking to a project engineer, a site manager, project manager, an ecologist, various different roles, none of whom are silt control specialists. So there is a knowledge gap there. And there's certainly different ways of approaching that. Sessions like this are really useful. More in-depth training can be done. At the other end of the scale, just a simple toolbox talk on site, perhaps, to tell people that silt's actually a pollutant, what to do, how to report it. These are all things that are going to contribute to sort of building a slightly more resilient system. Consider minimum standards for key roles. And I guess this comes down to the fact that, this is a technical discipline in its own right. But it's not all that complex. And if you understand the principles and get that in place, then actually a lot of problems can be prevented. There's no excuse for this anymore. If you're on a construction site anywhere in the UK for more than a few months, you're going to be dealing with surface water. And it's not acceptable to wait for something to happen, wait till you've got a notification off the regulator to actually do something about it. Pollution prevention needs to be planned, it needs to be put into a budget, it needs to be included in tenders. There's certainly process issues here. It's not high enough up on the agenda at the moment. And I think, we've got to ask ourselves as an industry, there's environmental risks, there's legal things we've got to handle, but we've got to ask ourselves if it's actually socially acceptable to be polluting a river in this day and age that people want to use for amenity value, or that's got a high biodiversity function, and it's not. surface water management, yeah, we do come across that too. I think the biggest issue here is we sometimes see a disconnect between the surface water management plan as it's written and what's going on site. So I guess there's a need to update that plan, evolve it. The problem is that ultimately, if your plan doesn't represent what's going on site, then there could be pollution pathways that you're not aware of. So this is one for you environment managers out there, environmental advisors on site. Try and get this on the agenda. If different pathways open up on site, you've got a different silt pollution risk. So you need to be aware of them. And if you can't get on a progress meeting, get it in the appropriate forum, but make sure you're updating it. We always advocate having a smaller, lighter surface water management plan, a map that you can adjust, that you can move around and look at, rather than a big, thick tome of work, because one of those is actually going to be useful to you, and one of those is actually going to help you prevent pollution. The other isn't so much. One of my favourites here is the lack of site investigation we see. Often we'll go to a site, we'll see a lagoon full of water that's just a colloidal suspended silt. It's never going to settle down. I'd probably rephrase this. Sometimes it's not a lack of site investigation because the SI happens, the ground investigation happens. It's more about how that information is interpreted and aligned with the intervention strategy. Now, I'm not a mathematician. I probably couldn't explain Stokes' law to you particularly well. I might just about be able to manage silt settlement area on a good day. But what I can do is I can take a sample of subsoil, put it in a glass or a container with water, shake it up, and see how long it takes to settle out. And ultimately, if that's still in suspension after a few hours, you're going to need more than a hay bale and a bit of silt fence to actually solve your problems. So understanding that at a very early stage is going to help you define your intervention strategy. If you're only finding that out when you're on site, you're already up against it. And if you don't have good planning, you don't have the skills on site, and you don't really understand the site, you're going to end up with inappropriate intervention techniques, and that's going to lead directly to silt pollution. I'm not entirely sure what's going on here. It's either very optimistic or tokenistic, and one of the two, possibly some sort of combination on a Venn diagram, I'm not sure. But yeah, this is an example of what not to do. So how are we going to assess risk on site? What are the main factors we look at? And this is taking aside factors like variables like the weather, we know it's going to rain at some point, and variables like the sensitivity of your receptor. This is just thinking about physically, how is silt going to move around site? We want to be thinking about the proximity and the connectivity of your receptor, whatever that receptor is. So that's thinking about how close you might be to a river. Are there ditches that link to that river? How is silt going to move beyond your red line? Topography, what's the nature of that subcatchment? How is it going to behave when it rains? Is that a peaky hydrograph? How fast is water going to leave site? And also geology, coming back to that particle size again. You might have a brilliant bit of site investigation, a really, really thick report that you paid thousands of pounds for. But if you're not interpreting that information and actually using it on site, then you could be doing better. So what are the main pollution sources on site? Unmade ground is a big one. So when you strip soil, you're leaving an exposed ground that can mobilize really easily when it rains. Pumping out excavations or ponds, tracking vehicles and ditches and streams. Unlined ditches can be a big source of silt pollution if they're not designed correctly. And poorly managed stockpiles. Your material management on site must interface with your surface water management plan. So going from source to pathways, what are the main pathways? Well, typically your water is going to be carrying your suspended load off site. So that could be down a drain, it could be down a surface water drain, it could be down a land drain, through a culvert, overland flow. There's all sorts of ways that water will move off site. It'll follow the path of least resistance. But understanding where those pathways are and how they change during the course of a project is really critical. And I'm thinking about receptors too. We've talked about the biosphere, potentially impacting rather the food chain. It's not just that though. You could be thinking about third-party assets downstream, fisheries, people or companies with abstractions that might want a certain water clarity. So don't limit your thinking to the biosphere when thinking about receptors. Think about third-party assets too. So we like to think of controlling silt as sort of a hierarchical approach, and going back to that source again. What does source control look like on site? And I think that there's a parallel here with health and safety. You don't put on your PPE as a first line of defence. Your PPE is there as a last line of defence. And you could see sort of silt capture and treatment a bit like that as well. If we can eliminate a risk at source or reduce it at source, then we can typically reduce the problem. So what does that look like? Well, we see a lot of scorched earth policies when ground workers want to come in, strip an entire site as quickly as possible, because economically that probably makes sense. But it's really worth giving consideration to a phased land strip, retaining vegetation buffers where you can, because that vegetation is going to be your friend. It's going to help you reduce the impact of silt pollution. Now, I know economically that's not always practical to do so. And certainly, there's an interface here with ecology as well. You don't necessarily want to be leaving lots and lots of vegetation around site that you might get something, a nesting bird or something that might be causing you problems down the line. So there is a balance here and different things to consider, but where you can, vegetation strips are really good, and a phased land strip can certainly help you out. Where you've had to sort of employ a scorched earth policy and strip all your land, and you're not going to necessarily do anything with some of that land for a bit, consider reinstating it. Erosion control blankets in high risk area, hydro seeding can be really useful. There's lots of different proprietary stuff and tools out there that you can use, that if that land's going to be sat there exposed for a year or 2 years, there could be a strong cost benefit argument for actually reinstating it rather than just letting it pollute or be a risk of causing silt pollution for that length of time. Stockpile management, I think I alluded to the fact earlier that you need to control, or rather you need that interface between your surface water management plan and your material management plan on the site. So unmanaged stockpiles, poorly managed material on site can be a significant source of pollution too. That's not difficult to manage at source. So just controlling the movement of that, sometimes covering stockpiles, sometimes getting a well-designed fence around it can really help reduce pollution risk there. We do see quite a lot of issues with temporary water crossings. We've seen quite a few fines as well directly relating to the fact that there have been vehicles tracking through streams on site. They've been causing all sorts of pollution issues downstream. But temporary water crossings is something that we do see not done particularly well, and so much so that we've done a guidance note on it to help some of our customers. Simple thing, needs a bit of planning. If you get it right at the start of your project, then you can really reduce a lot of silt pollution risk at the source. And although ditches are a way of moving water around site, unfortunately, if they're not designed well, they can be a significant source of pollution. So lining ditches, stabilizing them, particularly if you're going to be using those ditches to carry water over a number of months or years, that's really going to pay dividends to do that. And we have seen some pretty terrible cases whereby a site's been up against it, and they're trying to clean water and get it off site. They're cleaning water, but because they're transporting water in a muddy ditch, they're having to clean it again ultimately afterwards. So that doesn't make any economic sense. So it's worth investing in good ditch design and actually lining and stabilization as well. So if you've done everything you can to control the risk at source, let's look at drainage. That's really what comes down next in terms of the hierarchy of control. This does come down to good surface water management planning, keeping clean water clean. So quite often that might mean actually diverting water around your site rather than letting water come through your site. Think of it in terms of, if you had to put a pound and pence sign in front of every bit of silty water you had to treat, you'd want to minimize the amount that was coming on your site. Now, obviously, you can't put a canopy above your site and stop rain from coming onto it, but some really a good planned approach where you're thinking about minimizing water coming onto your site from third-party land can actually save you a big headache later on in the project. Infiltration is really useful where you've got ground that will infiltrate, but by all means, it's a good thing to use. And having earth bunds there to support infiltration in appropriate places can play a really useful part in your drainage strategy. Equally, over fields, green areas, where water can infiltrate, that's a useful thing to have if you've got permission to use it. Attenuation design is absolutely critical, and there's a couple of different angles here, aren't there? Because with attenuation design, you've got a maximum flow rate that you can release off site. So a lot of the attenuation is going to be designed according to LLFA requirements. But your attenuation design can play a critical role in your silt control, in your water quality. So there's a water quantity function and a water quality function here. And good attenuation design is not just about keeping that water back, it's about working out how you can use that pond to maximize retention of silt and actually keeping it back and not letting it go off site. If you're pumping or having to pump out ditches or areas or ponds, pumping technique's really important. Having a floating pump head so you're drawing from the surface, or basically not drawing from the depths where you're going to be pumping out sludge and letting that travel around site. So finding some way of protecting that pump head is really key. I'm going to come up and talk about ditches again, because again, stabilizing or lining ditches, it is really important. I think that it's really worth reiterating that a ditch on site can be your best friend or worst enemy. If you treat it well, if you design it well, line it, vegetate it, you can then use that to actually capture silt. That can play a really significant role in reducing your pollution risk. If you treat it badly, it's going to be your worst enemy. It's going to keep being a source of pollution throughout the course of your project. So really, due investment in ditch design and stabilizing early on, if they're going to be in place for a long time, particularly, will pay dividends later on in your project. So if we've done everything we can to control risk at source, and then we've looked at how we can manage drainage, I guess next down the hierarchy is actually silt capture. How do we capture that silt and keep it on site? Before we get into that, I want to just take a step back and think about what are we trying to do? If we're asking any technique or proprietary product or tool to actually control silt for us, what are we asking it to do? We're asking it to separate water from solid. We want to keep that solid back. We want to release the water from site, clean water from site, preferably, or a permissibly dirty level of water, depending on what your permit says. That's all we're doing here. So let's just keep that in mind when we're looking at through some of these solutions. Now, why is that sometimes easier said than done? Why can't we hold that silt back very easily sometimes? And it comes back to our friend particle size. Again, if you've got very, very small particles, that some of these particles might be 0.2 to 20 microns or something, absolutely tiny. They're going to stay in suspension indefinitely. So even in lab conditions, it is difficult to get them to settle out. So you can imagine where you're trying to get them to sit out in a treatment lagoon, where you've got inputs of energy from water or wind. They're never going to settle down. So that's a big problem for a lot of sites that we come across. Just try and imagine, I suppose, try and sort of visualize yourself next to a stream that's flowing, and let's imagine you throw in a bit of gravel, and it's going to pretty much land by your feet where you throw it in. Now, let's say you throw in some coarse sand, it's probably going to travel a bit further down potentially, and then some fine sand, it's going to travel further. You put in some clay, it's going to travel indefinitely. So the smaller the particle, the less energy it takes to mobilize it and to keep it mobilized. And that's why I'm going to keep coming back to this point and sound pretty boring, that understanding your particle size is one of the most important things you can do early on in a project. Now, where you have got really small particles, we use a technique called flocculation. And with flocculation, what we can do is we introduce an element into the water that can bind those particles together. So you've got millions of particles all swimming around together. Swimming is probably not the right term for particles. But if we can introduce a flocculant, we can bind them together, make them into bigger particles or flocks. They become energy limited, then they fall out of suspension. So that's all we're doing with flocculation. And I'll give you an example of this. So what you can see here is some nice clay samples from the site. We've added a flocculant to that sample there. You can see settling. You can see those particles are big, and now they're sitting down. They're separating the solid from the liquid. so that you can ultimately discharge that clean water and keep that solid on site. So this isn't a deep dive into flocculation. We do cover that in our half-day training session. I'd like to just give you a couple of takeaways about flocculants before we move on. You do need a permit before you use a flocculant or a coagulant on site. And the fallback position of the regulators, the EA, NRW, CEPA, NIEA, is that you don't use one. That's the fallback position. And ultimately, that's because some types of flocculant are ecotoxic and you could cause a problem. So if you do have a problem site and you've got clays, don't go online and buy a flocculant. Engage with a specialist, make sure you're getting the right product and make sure there's due diligence around that supply. Understanding that settlement characteristic informs the control strategy. So there's a straight line, there's real alignment between how that particle behaves, how you can drop it out of suspension, and what your pollution control strategy looks like on site. Now, permitting is an issue here because at the moment, if you want to apply for a bespoke permit, particularly through the EA, you're waiting months and months. Now, you need to understand if you need to have a flocculant early on, when you're applying for that permit, so that you can introduce that into at a permitting stage. You don't want to be on site finding out you've got an issue, finding out you need a flocculant, then having to adjust your permit. So again, kind of comes back to the planning side of things. And we have produced a sort of 5-minute read on flocculants in the construction industry. Very happy to share that with you all via Peter if that's of interest to anyone after the session. So let's look at a few different techniques that are commonly used on construction sites. Silt fence to start with, the old classic. It's cheap and cheerful, and it can be really useful if it's deployed correctly and if it's maintained correctly. The problem we see with silt fence is that it's not deployed correctly and it's not maintained correctly. So where it's good, it's really good. You think about what's going on there. It's breaking up the energy. It's reducing the energy. It's reducing the energy of that sheet flow. That means the water's got less erosive power to actually pick up those particles. It's helping particles sit down behind that silt fence there. So technically, it's got a really good function, but it needs to be used properly. And we'd really advise, if you are using silt fence, get it trenched in and make sure you've got a maintenance and monitoring plan as well. Rock checks are used quite a lot in ditches, so clean stone. We see this as a really useful function, actually, in all sorts of ways. I mean, it's just reducing that energy, reducing that erosive force of the water, having clean stone in there, quite often used in combination with flock mats or silt mats. If you've got an extensive drainage system and you've got plenty of stone on site, then it can be a really good way of just reducing the water, giving a bit of a filtration function as well. Hay bales, because we do still see hay bales used on site. I think a hay bale is a really, really good way of transporting hay in an efficient way from A to B. It's not a really efficient way of controlling silt on site. So I'd say that it's a big indicator. If you are still using hay bales on site frequently, you're using them a lot, it's an indication that you probably need to up your game a bit, ultimately, because they're not really fit for purpose. A hay bale lined in geotextile is also still a hay bale. So yeah, it's good to move your game on. And there's lots of different ways of actually controlling silt other than hay bales. Like silt wattles are really useful. Silt sausages, anywhere where you can ultimately reduce the flow of water and trap silt behind a product like that, you can reduce the energy and actually control silt pollution. Silt wattles can be used alongside things like silt mats and flock mats as well. So you've got water hitting that product, the silt's dropping down behind it, you're reducing the energy, you're reducing the flow, and actually you're trapping that silt on another product. Flock mats and silt mats are used a lot on site. Flock mats have got a treatment function, so they release an anionic flocculant as the water that flocculates particles that's then captured further downstream through silt mats. It's a really common technique we see used on a lot of different sites, but it's important that the flock mats go upstream they contain a flocculant, and the silt mats go downstream, because the silt mats are designed specifically to actually hold on to those particles, even in pulse flows. Another technique on site, which we're not entirely sure about, filter socks and bags can be useful on site. Unfortunately, we do see problems with them too. The issue here is that if they're not used to the manufacturer's instructions, then typically that's going to cause a problem. So each of these products will have a maximum flow per area of fabric, and it will have a minimum particle size that it can hold on to. The problem you get with these is that someone looks at it and think, right, I'm going to stick it on the end of a pipe and it's going to solve my problems. And that means that we do get to a lot of sites where we see big holes blown in the sides of these bags and silty water pouring out. Now, that's not the manufacturer's fault. The product itself is going to be perfectly good. It's what we're actually asking that product to do on site that's the problem. So not understanding the technical limitations of it. Another example, this is a good product. In its own right, it's absolutely brilliant, but is it being used correctly here? Definitely not. And there's absolutely nothing wrong with that product in its own right. It's the manufacturer manufactures that to a certain specification to do a certain job. And again, it's that there's a disjoint between the specification of the product and actually what we're purchasing, what our expectations are that it can do. And again, this comes down to particle size. You're not going to be able to capture clays at any kind of decent flow rate with products like this. Gully bags for another one. I would be wary again. They're really good for collecting debris and larger particle sizes, but just sticking something down a drain and thinking it's going to solve all your problems, it's not. There's again lots of really good proprietary products on the market. They've got a function. They're really, really useful, but we need to draw that connection between the specification of the product, its technical limitations, and what we're actually asking it to do. And that's where there's a disjoint here, certainly. I'm sure many of you here are familiar with treatment tanks. Treatment tanks are really, really good, really, really useful. There's, I think, 4 or 5, maybe 5 or 6 really good companies in the UK now that are supplying technical services around treatment tanks. And treatment tanks work in a way to increase the effective surface area of the particle. So you can capture more particles in a more condensed space. So typically we see treatment tanks used a lot on sites where there is a small footprint. There's no real room for lagoons or much attenuation. That's when treatment tanks can really come into their own because of the treatment they can provide in a very small footprint. They do use coagulation or flocculation, sometimes and buffering solution as well. So often treatment tanks will become a 2 or 3 stage process. So you might have a dosage area, you might have a settlement area, and depending on the type of coagulant used, you might also have pH adjustment before that water is discharged. One of the downsides of treatment tanks is the cost. It's not unusual to see higher costs in excess of a few £100,000 for a couple of years of work. And the key metric here is actually thinking about how much it's going to cost you per cubic meter of water treated. And certainly with traditional methods like hired treatment tanks, that can range from 50, 60p to beyond £1.50 a cubic meter. And that's why we advocate something called more of a rain-ready approach on site, which can significantly reduce the costs and carbon footprint of silt control. So a rain-ready philosophy, what's that? It's getting a system in place early. It's understanding the site, it's getting a good planning, and it's making sure that your site is ready year-round for any problem that might hit it. There's no higher cost associated with a rain-ready approach. It's only operational expenditure for consumables. And it does give the opportunity to actually reduce the need for pumps on sites. There can be cost and carbon savings there. Rain-ready doesn't typically have a liquid dosing, liquid coagulants, buffer solutions, or dosage equipment too. So how do we do that? We use something called a gel flocculant. And this is becoming more and more common in the construction industry. These are a very slow dissolving, stable 2 kilogram block. And these can be deployed on site to actually treat muddy water and get it settled out in the right place. Some of the key characteristics, it activates on contact with water, but deactivates when there's no flow. They've got very slow degradation rates. So in pump systems, they can last as little as 30 days, but in passive systems where they're being used intermittently, they can last over 180 days. It's environmentally safe, cited on numerous permits across the UK too, and recognised as a controlled dose. So that's what it looks like, gel flocculant block. How do we put it on site? Typically in dosage apparatus, such as a pipe reactor. So there's 5 blocks in there. That's linking to a 4-inch barrier connection and a pump system. So that can pump up to about 1,800 litres a minute. And downstream, we're putting things like silt capture channels or basins, or ultimately any area where you can reduce the energy. Remember the principles here. We've got water coming out of a pipe at high speed. We want to reduce the energy. We want to reduce that flow rate. We want to provide media for those flocculated particles to actually be captured. So a system diagram of that, you'd look at attenuation, a pump, a pipe reactor, option of 1 or 2 silt capture channels before your monitoring point and your discharge. And that's a system that was actually used to great effect in the Lake District quite recently. I say the project wrapped up quite recently. It's been used there for the last 5 years. And that was taking NTU down from 3,000 down to about 29. So really good performance. But the interesting thing was that it was also taking the chemical oxygen demand right down. It was also reducing the phosphorus without any change to pH, and no peaks of acrylamide, obviously polyacrylamide block. There was no peak of acrylamide beyond drinking water standards. You can imagine working in the Lake District. There's quite a rigorous stakeholder group overseeing this kind of thing. So environmental sensitivity was an absolute key point. An advanced JV, we're very happy with that as well. It meant they could keep working, ultimately keep discharging water. The interesting thing here of using this kind of approach is the cost saving overall. Having 2 pipe reactors and 2 silt capture channels on site and using a gel flocculant system meant that they spent about £40,000 or £50,000 over the course of 5 years. Not a huge amount of money, but if they'd had to have 2 higher systems in place with 2 or 3 stage treatment, they'd have been looking at costs of well into the 7 figures for that period. So I think it's useful to look at that, because ultimately we do have to look at our costs. The state of the economy at the moment, there's a big pressure to reduce costs, and silt pollution, managing silt pollution, particularly in the construction industry, is an area that is ripe for innovation. Now this gets really interesting, where you can actually remove the pump as well, because if you can use the flow of water flowing off your site to actually create treatment ditches and treatment areas, then actually you can use passive deployment techniques, and you can completely reduce the energy out of your silt pollution control. We've done this on a number of sites now, and early engagement is quite useful, because that can help us look at deployment areas, what ditches to use. But it's a very good technique, and ultimately I think it's the only technique I'm aware of that can actually reduce the impact of clays on site without using any energy or power. The real advantage there is if you can reduce a pump from site, then you are saving money. Probably somewhere between £15,000 and £20,000 a year if you can remove a pump on site, including fuel costs, which are more significant. At the same time, you can save 10 tons of CO2 over the year, which I'm reliably informed by our sustainability specialist. That's about the same carbon emissions to heat 4 homes for a year. Now, the efficacy of actually using passive deployment techniques is different from site to site. So if you've got a tiny footprint and not much space to move and not much treatment area, then yeah, it's probably going to be more suitable for a silt tank type system. Whereas if you've got extensive drainage, you've got some topography there to work with, then that might mean the site's open to be able to actually use passive deployment techniques, which can save a lot of money and a lot of carbon. Before I wrap up, I do want to give a nod to monitoring We're seeing a lot more self-monitoring on site. That little gizmo you can see down there in the bottom left is a turbidity meter. And more sites are using these just to ultimately be empowered, have that data to make sure that they are not polluting from site. One thing I'd say about monitoring, particularly quantitative monitoring, is that your data is only as good as the person looking at it and interpreting it and acting on it. So make sure you've got that management system to actually back up that monitoring as well. Make sure there's a written procedure there. Make sure you've got a threshold that you're working to. So yeah, that's important. And monitoring in general is very important because it's going to save you from having a pollution incident, actually keeping an eye on what's going on site. I want to just dial back to what we said we want a silt pollution solution to do for us. We want it to hold back solids, and we want to discharge clean water, or permissibly clean water. So it doesn't matter what you're using to do this. If you're using a silt tank, a capture channel, a bag, a silt wattle, a silt mat, whatever you're using, a lagoon, it's going to accrete silt. Silt's going to accumulate in it. That's the job that it's doing. So as far as I'm aware, there's nothing on the market that will teleport that silt to a different dimension. So that means you're definitely going to have to bring in a maintenance plan to make sure that that product, if it's a proprietary product or whatever it is going to still do its job. That's going to mean emptying it of silt, making sure it's still working, having a regular inspection plan. And again, this comes back to your planning and your environmental management systems on site. There's no point in putting a good plan in place and it being great for the first month and then it going downhill. It takes effort, it takes maintenance, and it's going to take some resources to get this right. So a couple of summary points to take away. First of all, silt pollution is an environmental risk. We know the damage it can cause, but we're also seeing the business risk increase measurably over the last few years. And our view as practitioners is that the construction industry can do better and should be doing better at the moment. There's multiple underlying reasons for silt pollution incidents happening. Understanding those underlying reasons can actually give the opportunity to fix things in a more process-driven way, in a systematic way, and that's going to reduce the reactivity, the sticking plaster approach. So looking at those processes, asking the right questions at the right time, thinking about settlement testing, thinking about particle sizes, thinking about introducing flocculants into your permit application if necessary. And that planning is really going to reduce your risk. It's going to save you money, it's going to deliver efficiencies, and it's going to deliver you a carbon saving too, hopefully. Communication is really important. Developing a baseline of knowledge for all staff is really useful, from the toolbox talks to CPD sessions to half-day training sessions. Actually, just raising that bar of knowledge is a critical component to getting this right. And there's definitely a skills gap in the industry with regards to managing silt pollution. Lastly, I'd say that getting silt control wrong can be really expensive, but getting it right can be very expensive too. This is an area that's really ripe for innovation, but you shouldn't be looking at your technical approach as your first fix. You can spend as much money as you want on the technical fix, but if you're not getting your basics right with your surface water management and your planning, then your site is always going to be at risk of causing a silt pollution event. So that was my last slide. Thanks very much for joining for this one. Any feedback you'd like to give, if you've got a smartphone, you can actually just scan that now. It's really useful for us to get feedback, good or bad feedback. We prefer good feedback, obviously. But yeah, thanks very much for joining us today, and I'm very happy to answer any questions.
Well, Richard, thank you for that really insightful look at silt on the site. I thought it was really interesting, and you raised some great questions yourself. And I just wondered, before anybody else can chip in, we have got one comment just in the Q&A actually about sharing the slides. So from Risk Brindle, yes, we will be sharing those slides. That won't be a problem. We can sort that out in due course. As I said, if anybody else has got a question, can you stick it in the Q&A? That would be good if you could monitor it. But just to reflect on your presentation, Richard, I think there's some really good points. One of the things that certainly I'm personally aware of is as you said, the increased reporting from the members of the public. By virtue of, I think more people have been out in the last 3-4 years. They've found walks and trails which possibly go next to construction sites, and have seen incidents. And I know, speaking to the Environment Agency, that is the case. So it's a good shout. I just wanted to touch very briefly on the skills gap that you mentioned, and it's something that CECA is certainly more than aware of across a whole range of activities. I mean, is there anything in particular, other than obviously your good selves in terms of your organisation, of how we as an industry might be able to move that skills gap along? Because as you say, without that fundamental knowledge, we're going to be continuing to make those same mistakes.
Yeah, I agree. Something we identified when we've worked closely with companies on this is identifying what role should have what skills, and trying to map that out. So certainly, a project manager or a program manager doesn't need the same training or different type of training to a digger driver or someone on site. So clearly, training and sessions like this do play a role in just raising the awareness, but also making sure that the roles within a company do have the right training as well, and they've got the right background, and just trying to build a bit of capacity in-house and a bit of knowledge in-house, I think, is a very useful thing to do.
Right, yeah. And you're just another thing as well, and perhaps just to everybody else listening, rather than use the Q&A, if you wanted to refer to revert to the hand up icon, that might, if you feel more comfortable just doing that would be useful, just to try and get some engagement going. There are some from my environment group which I'm sure will be burning. There'll be questions to be asked, so please chip in. Whilst they're thinking about that, I've got another one for you, Richard. You mentioned early engagement. Just out of interest, because we talk about early engagement within the construction sector, about the teams coming together, and I suspect you're right that the management plans, the silt management plan or water management plan, probably come quite low down on the list. How do we get that around the table at the start of the project so people can start to think about the planning needed?
I think it's very, very difficult, and it's going to be different for every single company, because they're going to have a slightly different process, slightly different protocols, slightly different documentation. One of the most interesting pieces of work I've engaged with over the last few years is looking at pre-start meeting documents, pre-start 1, pre-start 2, pre-start 3, and just looking at trying to map where on that process the right questions to ask are, where budget needs to be built, where resource needs to be dialed in to actually keep that sort of surface water management side on track. It's usually very closely associated with the permitting requirements ultimately. So that does help, but that's certainly just thinking, okay, we've got a permit there, we have to have a surface water management plan, isn't the right approach. It needs a better level of engagement with the right professionals at the right point.
Okay, no, thanks for that, Richard. Is there anybody else? I know we're coming close to 5 o'clock, but so maybe everybody's got tea on their brain.
I've got some Q&A questions here. I don't mind reading them out and trying to.
Good.
In fact, I apologise to Natasha Wost, because you've asked me a question about open cast mining with a porous substrate and sinkholes, and I'm probably going to be running out of skill if I try and talk about that. But if you do want to contact us offline, that's something certainly we'll certainly be able to have a look at that for you and see if we can assist. Got one from Charlie here. Is there any method of deciding what particle size you're dealing with on site so that you could know whether you need techniques like flocculants? the regulator are going to want to know, have evidence the fact that you've been through a process there to define whether you need a flocculant or not. So settlement testing is a really good way of doing that. There's various different companies that will do that for you. Ultimately, just be measuring the size of that particle, measuring how quickly it falls out of suspension. If you wanted to look at it on a sort of technical front, 0.63 microns, I think, is the limit for silt and fine silt. That's typically the particle size where you're going to have more difficulty pulling that out of suspension. But also there's lots of variables here, because if you've got a massive lagoon and loads of treatment space, then you might be able to handle a smaller particle size without flocculants. So a bit of a moving feast there, and because you've got quite a few different variables, there's not one answer. But certainly that 0.63 micron size is certainly a bit of a threshold from a technical point of view where you might be having difficulties. I've got one from Joe here. In the infrastructure environment, what are the best products to use when working on roads to minimize release of silt into surface water and foul drains? Interestingly, I just had a meeting about this earlier today, and it's a recurring one, actually. And the thing about working on roads is and sort of linear projects is you've typically got sort of like the holy trinity of things that can go wrong with silt pollution. If you've got fine particle sizes, you need to discharge at high flow rates, and you've got a limited treatment space, you're going to be up against it technically. So I don't think it's a case of finding there's no best product, because there's no one answer. It's all about finding out where you've got, what you've got, how much room you've got to play with on site, sensitivity of your receptors, your treatment spaces. There's just so many variables, and I guess that's why it's an area where it is a technical discipline in its own right, because it's about finding the right tool for the job, and there isn't necessarily a one size fits all. So I'm sorry, that's a bit of a flaky answer, but it's probably the best I can do at the moment. And I don't think there's anything else in the Q&A.
There's a few more. So there's one from Matt Phillips on how do you manage situation in ditch clearance operations when the ditch contains water voles or other sensitive receptors? What permits, if any, are required?
So again, this is an area I'm going to run out of skill because it involves water voles and ecology. Look, water voles, the bottom line here is that water voles are legally protected. They're an endangered species. If you're doing anything around water vole habitat, I would be very, very careful, consult a professional ecologist, and make sure you're doing the right thing, because you can get in a lot of trouble for damaging water vole habitat or causing injury to water voles, and the water voles don't like it either. So that's important to note. I can't see any more Q&A, so if you can read any more out, that would be useful.
I think there's one more. Have you answered that many of the approaches here are larger scale long-term projects? Is there a different approach to silt control for smaller schemes and maintenance jobs that may only be on site for a day?
Yes, yeah, absolutely. I mean, some of the solutions here can be used on smaller sites. Things like jetting culverts, for instance, where there's cyclical maintenance that needs to happen. Things like silt mats and flock mats can be used to great effect in those kinds of environments. Ultimately, it doesn't matter how long your project is. I mean, it's going to change your permitting requirements if you're doing a maintenance project as opposed to being on site for months and months or years. But you're still going to have that responsibility to control a pollutant from site. So the same principles apply. You need to understand, if you're jetting a culvert, what are you jetting out of there? What's that waste material, and how can you best capture it? There are plenty of solutions for that, but with this kind of thing, try and keep it simple. If you've got difficult sites to access, you don't want to be hauling loads of infrastructure and plant there necessarily. So a bit like the same principle as monitoring, try and keep it as simple as possible. Try and come up with a practicable approach.
Okay, thanks, Richard. I think, does that conclude the questions there, Felicity?
I believe so.
But
if anyone else has any questions, they can unmute and ask them.
Yeah, anybody else would like to raise their hand and ask a question?
Oh, sorry, I just wanted to go back to Matt there, because I've just seen that, because he also asked about permitting as well. Matt, it's a bit of a complex one, but again, feel free to contact us offline, because actually we've done some training around this recently, and we've come across this quite a bit for short-term sites where there's things like sewer bursts, mains bursts, culvert clearance. I'm really happy to talk through this kind of thing. We're very geeky when it comes to silt. We like sort of talking about technical challenges and sharing our knowledge. So I'm always happy to have a chat about that.
Okay, thanks, Richard. Well, perhaps we could leave it to that then. And following on from that, I think almost unwritten, reading between the lines, that kind offer of responding to anybody who has got a query following this session, and obviously once they've had a look through the slides, if they've got a follow-up question, then they perhaps can get in touch with you directly. So I think all that leaves now is just to say thanks ever so much again, Richard, for stepping in at last minute. Leila, I do hope your voice recovers and your infection gets better quickly. I know what it's like, so fingers crossed that's all good. And I just wonder how you might be affected by Storm Babette that is on its way, that you may well be inundated from contractors who've got flooded sites. So you never know. Thanks, Felicity, for setting this up as well. I know you've been instrumental in this organisation, or the organisation of it. And thanks to everybody. I think we had about 35 attendees at the peak, so that was pretty good. Thanks to everybody, and have a great evening. So thanks for that.
Thank you very much.
Thanks very much. Good evening.
Thank you.
Cheers.